class, it's Amanda and Taylor. Today we'll be talking about the Hardy-Weinberg theorem and how it relates to biology.
Oh, Amanda, what's Hardy-Weinberg?
Hardy-Weinberg is a principle for comparing allele frequencies in a given population over time. A population of alleles must meet 5 assumptions in order to be considered equilibrium. If a population does not meet 5 of the assumptions of Hardy-Weinberg, then a change in the gene pool has occurred. It is highly unusual for this to happen in nature, though.
So, what makes something in Hardy-Weinberg equilibrium? There are 5 assumptions that have to be met for something to be in equilibrium, which are no natural selection, isolation, large population, no net mutation, and random mating. And if all of them are true, then it's in Hardy-Weinberg equilibrium. But there's no existing population in nature that actually is in Hardy-Weinberg equilibrium.
To be able to calculate the change of the gene frequencies, we use the Hardy-Weinberg equations, which are P plus Q equals 1 and P squared plus 2BQ plus Q squared equals 1. If the sum of your equations does not equal 1, then the change has occurred in the gene pool. If your equation does equal 1, that indicates that the population is in Hardy-Weinberg equilibrium. We love that. Sister science.
So, P in the equation represents the dominant allele frequency, and Q represents the recessive allele frequency.
So P squared, or little p, is the homozygous dominant genotype. Should I start over now?
No, well, it was like all
know,
the way up
okay.
here. Right.
So P squared, or little p, is the symbol for the homozygous dominant genotype, while little q, or P squared, is the homozygous recessive genotype. And then PQ together is the heterozygous genotype.
And now we're going to do a practice problem. So the problem is, you have sampled a population in which you know that the percentage of the homozygous recessive genotype, a, is 36%. Using that 36%, calculate the following. Okay, so we have a is 36%. So that's all we know. So first, we are finding the frequency of the a genotype. So that's pretty easy. All you have to do is make this a decimal instead of a percentage, which would be 0.36. So if it asks for percentage, it's an actual percentage, but if it's a frequency, all you have to do is make it a decimal, and it's a frequency. Part 2, the frequency of the a allele. So this is not a squared. This would be Q squared, because it's a recessive genotype. So Q squared is 0.36. We just take the square root and we get 0.6 for the frequency of the little a allele, because this would be the genotype and just 1 is the allele. So now we find the frequency of the big A allele, which is the dominant allele. So all we have to do to find that, which is P, is subtract this from 1. So 1 minus. So the frequency of the dominant allele is 0.4. Part 4. The frequencies of the genotypes big A, and big A, little a. So now we're finding genotypes instead of alleles. So we're going to use the other equation. Because this is what we use to find genotypes. So we're finding the big A, and the big A, little a. So to find the homozygous dominant genotype, all you have to do is take P and square it. Can you read that? And now we have to find the heterozygous genotype. So 2PQ represents the heterozygous genotype. So 2 times P 0.6 times Q. I really don't know what that is.
.48.
You did that in your head?
Is that 0.48?
Yes.
Yeah, because 6 times 4 is 24, but it's a point times 2 is 48. Good job, Taylor.
Good for you. That shows how much I learned in AP Calc. So, this is the heterozygous genotype frequency. And then, alright, this last one says, the frequencies of the two possible phenotypes if big A is completely dominant over A. If big A is completely dominant over A, what are the two possible phenotypes? The frequencies of them. So that means that the heterozygous, which is big A, little a, and the homozygous dominant, which is big A, are both going to be completely dominant. So they're going to show the same phenotype. So you add those together, and that will be the frequency of the phenotype for big A. So then the frequency for the recessive phenotype is just going to be 136, because that's the only one where the recessive gene is going to show. So that's, but I've never actually seen a question like that, but there you go.
So basically what we're trying to find out is the percentage of the hetero genotype. So if we only, so first off they gave us Q squared. So Q squared equals 9%. So like what Taylor did with the first problem, you just take the percentage and you can put it into a decimal. So it's 0.09% equals Q squared. So now we gotta square root this so we can find Q. So I'm gonna do that really quick. That gives us 0.3. So Q equals 0.3. Now we can find P because we know that the basic formula for allele frequencies is P plus Q equals 1. So what we can do is do 1 minus 0.3, which gives us 0.7 as our P or dominant allele. So now that we know both P and Q, we can plug it into the genotype equation, which is P squared plus 2PQ plus Q squared equals 1. So we're trying to find the hetero one, but we can still solve it anyway. So I'm going to erase part of this so I have room to work down. So we know that P equals 0.7. doesn't really erase well. But anyway, so you have 0.7 because it's squared equals PQ plus 2 multiplied by 0.7, 0.3 plus 0.3 squared equals 1. So basically we're just trying to find the hetero one, which is this one, but you can still solve the rest of it just to make sure that you do equal 1 when you do your work. So 0.7 squared is 0.49 plus 2, so basically mental math. Yeah, 0.21 times 2 is 0.42 plus 0.3 squared is 0.9. So if you 0.09, my bad. If you add all those together, 0.42, so that's 1, so that's 91 plus 0.09, which equals 1. But since you basically solved for all of it, now you can just say that the hetero PQ is 0.42, and that's the frequency for the hetero. That's it.
Yay!
Now that you know how to do the problems, good luck on your exam and other problems. We already took our exam, and it was a little iffy, but probably fine. Here's the meme.
Anybody, and I didn't see anybody to this point, and I think I heard voices. Are you still recording?
Video.
Oh, just hi.
You wanna say
Keep
hi?
going.
Come
Hi,
here.
this is Jenkins.
You're gonna be in it.
Sorry. Let them continue. Bye.
Yeah. Like and
You're
subscribe.
gonna do great. Like, subscribe.
Ring the bell.
What does that mean?
It's the notification thing.
Oh.
Oh yeah. Oh yeah. Oh yeah.
Ready? Catch it. By the time they're watching this, that's gonna be such an old thing.
It really is. I'm so sorry.
Watch
Things change. Please like, subscribe. Miss Jenkins, I hope Parker's great.
Have a great time.
We love him. We have a meme. It's gonna be posted after this
It
video.
was my favorite class.
Yep.
Hope you're liking it.
This is the only science I like.
We're both majoring in. Well, I'm in molecular biology.
I'm bio.
Biology. So you know we're gonna be experts. So you can just hit us up.
So yeah, just like if you need some help, just like ring my phone. Text my messages.